Good day. So our topic for today is about approximations and round-off errors. So we have here the numerical methods yield approximate results that are close to the inexact analytical solution. So how confident we are in our approximate result. In other words, how much error is present in our calculation and is it tolerable? So we have here the significant figures. So number of significant figures indicates precision. Significant digits of a number are those that can be used with confidence. For example, the number of certain digits plus one estimated digit. So in this example, we have 53,800. So how many significant figures we have? So we have 5 significant figures. So including 0. So 53,800 has 5 or having a 5 significant figures. So in this example, 5.38 times 10 raised to 4. So how many significant figures does it have? So meron niyang 3 significant figures. And ito naman ay merong 5 significant figures. So zeros are sometimes used to locate the decimal point, not significant figures. So for example, this one. So we only have 4 significant figures only, including here kasi trailing zeros yung andito sa start. So yung mga zeros na nasa unahan ay hindi na kinakount. Okay? Next, we have here the identifying significant digits. So all non-zero digits are considered significant. So for example, this one, 123.45. So all of the digits are non-zeros. That's why they are counted as significant figures, and we have 5 significant figures. So here, zeros appearing on anywhere between two non-zero digits are significant. So, lahat ng zero na nagpakita between sa dalawang non-zero, katulad nitong 101.1002, ay kinakount. So, yung 0 dyan is kinount. So, meron tayong 7 significant figures. Next, leading zeros are not significant figures. So, katulad ng in-example natin nung una. So, yung mga zero sa unahan, katulad nito, ay hindi kino-consider. That's why we only have 2 significant figures in this example. Next, trailing zeros in a number containing a decimal point are significant. So, for example, 12.2300. So, kinount natin yung 0 kasi andyan naman siya sa hulihan. Hindi katulad nung kanina na nasa unahan. So, including the zeros in the decimal places are considered as significant figures. So, we have 6 significant figures in this example. Okay. So, the number of this one, 0.00012230 still has 6 significant figure. Why? Because we have 2 zeros after the non-zero. So, yung zeros before the non-zero is hindi na-count. Okay? In addition, 120.00 has 5 significant figures. Okay? So, this one naman, the significance of trailing zeros in a number that not containing a decimal point can be ambiguous. So, for example, it may not always be clear if a number like 1,300 is accurate to the nearest unit. So, various conventions exist on other address this issue. Okay? So, now, we have here the error definitions. So, we have true error, and ito yung variable niya. So, E sub E. So, formula equals true value minus approximation. So, the true percent relative error or summation sub P is equivalent to absolute value of true value minus approximation divided by true value times 100%. Next, approximate error. For numerical methods, the true value will be known only when we deal with functions that can be solved analytically. So in real-world applications, we usually do not know the answer a priori. So for example, we have this the formula, approximate error, current approximation minus previous approximation. So formula for our approximate relative error. So summation sub A is equivalent to absolute value of approximate error divided by approximation times 100%. Okay? Next, iterative approach. So, example, Newton's method. Okay. So, approximate relative error is equivalent to absolute value of current approximation minus previous approximation divided by current approximation. Later, ma-apply natin ito sa example na isosolve natin. So, meron tayong tinatawag naman dito, kung yung E sub A, ito yung approximate relative error natin. Ito namang summation sub S, yan yung error tolerance natin, which is ito yung formula natin. Error tolerance is equivalent to parentheses 0.5 times 10 raised to 2 minus n percent. So, percent yan. So, yung tolerance natin is naka-percent. Error tolerance. Okay. Next. So, we have here the example number 2. So, Maclaurin series expansion. Okay. So, calculate e raised to 5. So, yung e raised to 5 natin, meron yung true value na 1.648721, then up to 3 significant figures. So, ang i-consider lang natin is 3 significant figures. During the calculation process, compute the true and approximate percent relative errors at each step. So, first, we have to compute the error tolerance. So, paano ba nakuha yung error tolerance na yan? So, ito. Error tolerance. Okay? So, ano yung formula natin? Summation S. Yan. Dito, yung formula natin. Ayan. 0.5 times 10 raised to 0.5 times 10 raised to 2 minus n. So, yan. Percent. Okay? So, yan. Formula. Next. So, yung 0.5, yan yung value ni x natin. So, times to, ito naman yung value ni x natin is equivalent to 0.5. And then, itong 3 natin, yan yung 3 yung significant figures. So, that's why we will have 0.5 times 10 raised to 2 minus 3. So, ano yung sagot natin dyan? Meron tayong 0.5 times 10 raised to negative 1. 0.05%. Yan. Kung paano nakuha si 0.05 na error tolerance. Okay? Next, we have here the terms. So, ano yung terms natin? So, ito yung terms natin. Diba? Yung e raised to x natin is equivalent to 1. X raised to 0, 0 factorial plus 1. Hindi pala 1. Alisin na lang natin yung 1. No? Alisin na natin yung 1. Kasi hindi din na naman pinoconsider. Okay, so x raised to 1 over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial. Ayan. So, ano yung magiging sagot nito? 1 plus, so ito, 0.5 plus 0.5 squared over, ano yung 2 factorial? We have 2 plus 0.5 cube over 3 factorial. We have 6. Okay. So, 1 plus 0.5 plus 2.5 squared divided by 2. We have 0.125. So, plus yan. Plus 0.5 raised to 3 was divided by 6. We have, so 0.020833. Okay? So, of course, ayan, yun yung mag-stop natin. So, 0.05. Ngayon naman, i-compute natin yung true value natin. Kasi, true value. True value. So, meron tayong given na e raised to 0.5. So, that means, x natin is equivalent to 0.5. But our true value is yung ito. So, e raised to 0.5 is equivalent to 1.648721. Okay? So, ito yung true value natin based dito sa given problem. So, ito siya. So, actually, may kadugtong pa yan. Itong true value natin. 1.648721.271. Okay? Pero ang nilagay na lang sa note is hanggang dyan. So, 1, 2, 3, 4, 5, 6, 7, 8. 8 significant figures. Yun na lang yung kinuha niya. Hindi pala. 7. Kasi hanggang dyan. Okay? Next. Okay? So, i-compute natin. Ipa-find out natin kung paano na-compute itong result natin. So, itong result, kinuha lang niya yung first term. Okay? Next, dito sa pangalawa naman, first term plus second term. So, 1 plus 0.5. So, ito siya. Okay? Next, ito naman, pinag-plus lang niya ito. So, itong third term. 1 plus 0.5 plus 0.5 square over 2. So, nakuha niya yan. Next, ito rin naman. Ganun, ito rin nakuha niya kanina. So, yan yung nakuha natin kanina. Ito, pag pinag-plus lahat natin yan, magiging anong sagot kaya? Equals 1 plus 0. 1.645833. Wherein, yung value na yan is ito. Diba? So, fourth term. And then, yung pangalawang term ay panglima at pang-anim. Nagdagdag na lang siya ng additional term, which is ito. Plus x raised to 4 over 4 prime and x raised to 5 over 5 prime. Kaya, kapag ito isinama niya hanggang ditong hanggang fifth term, makukuha niya ito, 1.648435. And then, ito naman, pag isinama niya itong x raised to 5 over 5 factorial, makukuha naman ito. Okay? So, nag-stop lang siya. Nag-stop lang yung pagkuha ng result at pag-count noong nakuha na itong 1.648 and 1.648. So, pareho na siya, diba? So, nag-stop na siya dyan. Kasi, almost the same na siya dito sa true value natin. Okay? So, itong result, considered yan as the approximations natin. Okay? Yan yung mga approximations natin. Ngayon naman, isosolve na natin itong true percent relative error. So, paano natin i-compute yung true percent relative error? So, ito siya. True percent relative error. Okay? Yan. True percent relative errors wherein yung formula natin, summation equals absolute value of true value minus approximation divided by true value times 100%. So, at first, itong part na to, at count 1, okay? So, ano yung summation natin? Ano yung true value natin? True value natin is 1.648721 minus yung approximation natin na 1 divided by 1.648721 times 100%. So we have here the ayan. So meron tayong 39.3. So 3 significant figures lang i-consider natin ha. So 39.3. So nakuha natin si 39.3. So percent 'yan. So that means maka-percent ito. Next, kukunin natin naman yung pangalawang for count 2. So count 2. At count 2. So we have summation of t, approximate value, 1.648721, yung true value natin. And yung na-compute natin doon is 1.5. 1.5 by true value times 100. So equals same thing, 9.02. So, remind ko lang, 3 significant figures. Next, we have the add count 3. Okay. Ano yung value natin doon? 1.625. Equals times 100, 1.40, ilan yung nilagay natin? 44. 1.44%. Okay? So, ganun na rin yung pag-solve ninyo sa mga sumusunod na mga value ni true percent relative error. So, ganun lang yung pag-solve. Okay? So, ito yung approximations natin sa result and then gagamitin lang natin yung true value natin. Okay? Next, paano naman makukuha yung approximate relative error? Relative error. Paano makukuha yan? Ano yung solution natin? Formula, approximate relative error is equivalent to current approximation minus previous approximation divided by current approximation times 100. Okay, percent. So, at count 1. Count 1. So, ayan. So, EA, anong current approximation natin? Ang current approximation natin, just itong 1. Okay? Yung 1. So, 1, absolute value of 1 minus, wala tayong, previous approximation. So, ilagay natin 0. Try natin. Sige, try pa rin natin. So, current approximation, 1 times 100. So, ano kayo lalabas dyan? Okay? 1 minus 0 divided by 1 times 100. So, wala. Diba? Wala tayong error kasi 100 pa rin yan. Diba? Kaya, yung nilagay dito, is naka-blank yan. Kasi walang error. Diba? 100 pa rin siya. So, that means walang error, approximate relative error. Okay? So, ito naman, pangalawa natin. Next, at count 2. Count 2. Okay? So, approximate relative error is equivalent to, so, 1.5 minus 1. So, 1.5, ito yung current approximation natin. Itong 1, ito yung previous. 1.5 times 100%. Okay, yung 1.5 is ito yung current approximation natin kasi nasa count 2 tayo. And then yung previous natin is itong 1. Okay, so anong lalabas? 1.5 minus 1 divided by 1.5 times 100. Okay. And then, ikino-consider natin is 3 significant figures. So, we have 33.3%. So, hayon na siya. Hayon. Next, at count 3. At count 3. So, approximate. So, current approximation natin is 1.625. 1.625 minus yung previous natin, 1.5. Okay? So, since nasa 3 na tayo, count 3, so ang current natin 1.625 and then ang previous natin is si 1.5. Okay. Times 100. Now, considering 3 significant figures, okay. Now we have 7.69%. Okay? So the rest of the counts, kayo nang bahalang magsagot. Okay? So mapapansin niyo naman, ayan. So dito sa true percent relative error, mapapansin niyo nababawasan yung error. So almost same na siya sa ano natin, sa true value. Ganon din si approximate relative error. Pabawas din ng pabawas yung yung tawag nito, yung discrepancy. To. Okay? So dito sa approximate, parang mas malaki yung yung pag binase natin yung percent na error niya. Okay? Kumpara dito sa true value. Okay. So, that's it. So, continue natin yung topic natin sa susunod na video. Thank you.